let us start today's session where we'll be discussing about sentiment analysis. What is it? How it plays an important role in our day-to-day life, how it drives our decision, right? A lot of decisions are based on sentiment analysis. Sometimes we do it unconsciously, right? So let's deep dive into the session. So let me start with a quick story about data science first, right? Because that's a mother field, right? Sentiment analysis is one use case. So let's start a quick story, right? We just had a World Cup, right? So cricket is still in our mind. So let me give you a simple question. In what innings Sachin didn't play a single cover drive for, I'm sure everybody is aware about Sachin and his famous his famous cover drive. But for those who don't know, just to set the context, Sachin is one of the leading cricket player, right? We consider him as God, most of us. And cover drive is his signature shot, just like you have helicopter shot for MS Dhoni, right? So that's a question, right? Interesting question. Now, what is the background? If I ask you this question, what is the background? Let me give you some context. Where does this question arrive, right? And where does data science plays a role in answering this question? So the background of this question is the batsman, the master blaster Sachin, was going through a very extremely lean phase. You have your downs. Sometimes things just don't work out, right? Where he just scored 88 runs in the last three matches, right? And these are test matches, so it's equal to 6 innings, six batting, uh, and only 88 runs, out of which three single digit scores and including two ducks, right? That was a very lean phase for our master blaster. But then what was the reason? The reason was in every match he was trying to play a cover drive, and that is where he got out most of the time, right? And there was this one match against Australia, unfortunately, Australia again this time, right? Where he scored 241. And the reason why he rose up, he broke down all the downs and went to a really great high was because he didn't played a single cover drive. Now, what is all these things? Why are we talking about cricket? Why are we talking about cover drive? Because this is an insight that was discovered by Brian Lara. It was Brian Lara who said that Sachin played such an amazing inning that throughout the inning, throughout that single inning, there was no single cover drive, which led to him scoring 241, right? Now, this is insight that requires experience, domain knowledge. Brian Lara is a seasoned cricketer, right? But if you and me as end users, as people, as data analysts wants to get this insight, how is that possible? That's possible only through data science. Data science is the field where you can answer all your questions, all the business questions, all the hypotheses, right? And find out those key insights that are lying somewhere in the data. Okay, so just a small story. What role can data science do? Yeah, in any domain, that right? Now that brings me to the next question. What is data science? I gave you a small story, but what is data science? Data science is an integration of three fields. What is those three fields? The business domain, the area of business that you are solving for. Second is mathematics and science, because you deal with a lot of data, right? And data is humongous. You always need to aggregate it, filter it out, do some processing, right? And because data is so huge, you cannot do it on pen and paper. You cannot do it manually. So for that, you require some computer systems. That is where the third part, IT and computer science, comes. To zoom it up a bit, this is how it looks. So on the business side, you have a lot of industry. You have Amazon on the e-commerce side. You have Netflix on the sorry, you have Netflix on the entertainment side. You have banks on the fintech side, and so on. Every company has its own data and its own set of unique challenges, right? Every company has its own unique challenges, right? Machine learning comes in solving those problems, but because there's huge level of data involved, you require some programming language, right? Humans can't churn out 1 billion rows, but if I have a programming language, I can do that using code. I can speak with machine and machine can do it for me. Yeah, so that is simply data science. So it's a sweet spot on and an integration of three fields: domain, because you need a problem, right, which comes through the domain, and two enablers, machine learning and a programming language to solve a problem. Okay, that's in very simple words. Okay, I'll skip this. So who is a data scientist? In my experience, a data scientist is anybody who solves a business problem using data, right? If you have a business problem from the domain, if you have the data, and if you can answer that question or solve that problem using that data, you are a data scientist in very simple words. Now, data can be in multiple formats. Data can be in textual format, data can be in tabular format, data can be images, videos, audio, or even maps, networks, right? And so on. So today we'll be looking at the textual part of data, right? And we'll pick one use case that, one of the many use cases many use cases are possible, but we'll pick one, which is a sentiment analysis. Okay. These are some of the industries where data science is happening, and this is not exhaustive because, as data science is growing and you are aware about the kind of evolution that is happening, right? I'm sure people are watching the AI space. How many people have, were paying close attention to the Chat GPT, OpenAI, and Sam Altman story? How many people? Can I get yes, no? So we have 40 people here today. Let me see how many people. There's a simple way also. So you can just so there's a option to raise your hand. Just raise your hand so that I can get a count. How many people were closely following what's happening in the AI space? Okay, I can see 15 hands raised. Okay, awesome, great. So there is a lot of movement happening in the AI space, and it's growing by leaps and bounds. The kind of progress it is making in the last 2 years is quite amazing, right? And the number of industries are just growing, and so this might not be the latest data, but it's growing very fast as we speak. All right, but we'll be talking about one industry, which is the e-commerce. This one. Okay, now let me take some time and explain you how does the industry works, because I have been into the industry for 10 years, so I have shared my experience here that usually for a non-data scientist, the hiring time is 6 to 8 weeks. I'm talking about average time, right? Some people hire in 1 week, some people hire in 3 months, so the average is usually 6 to 8 weeks. But for data scientists, right, it is usually 11 to 14 weeks as compared to the rest of the fields, rest of the technical fields. Now, what is the reason that the time to hire a data scientist is almost double? And the reason is the skill gap. Now, what is the skill gap? Because data scientist is the 21st sexiest job of the 21st century. We have lots of opening, right? We have lots of freshers coming in, but still there is a huge gap. Of course, data is growing, and so is the job around the data science, right? There's a lot of people who are interested to join data science, right? But there's a huge gap. What the academia does in schools and colleges is not enough, right? What industry expects is different. So while you are learning language today, after 3 years of your graduation or 4 years of your graduation, industry has changed, right? So you need to be up with the industry because industry is fast moving, whereas academia takes a huge time. And I'm sure a lot of you would already have seen that, right? Industry is running at a different scale altogether, right? So there's a lot of gap between what the potential candidates have to offer and what the industry expects from them. Yeah. And that is why the time to hire, although the supply and demand both are huge, but I would use the word quality supply is still less, right? And these are some usually salary ranges that data science people get. And I'm not quoting the number randomly, right? You can see it. These are screenshots from some websites, some job hunt websites, right? So premium companies like McKinsey and so on are offering 15 lakhs. This is the average salary in general, right? And we are talking about the range of 2 to 5 years, not freshers, but not too seniors as well, right? 0 to 5 years. Okay. Amazon 21 lakh, Google 24 lakh, right? Now these are just these are not latest numbers, but latest numbers are much higher. This is another analysis on the salary side where you can see that we have started from 3 to 6 years, the blue one, right? I think most of you are from 3 to 6 years. Just look at the kind of amount the companies are paying. And this is again outdated numbers. These are 2021 numbers. The reference image is here. And I'll be sharing the deck with you so that you can use the link again. Okay. So just look at the numbers, right? Now you would wonder, okay, will I get it? Yes, you can get it if you are a qualified professional, if you are a qualified data science professional, right? Not everybody can get it. But if you can offer what the industry is expecting, you can definitely get it. I myself hire a lot of freshers right out of college, right, who have the skill sets. Right? We live in time where college degree is not important. We live in a time where your break, your lateral company, the past company history, not important. If you have the right experience, right, in problem solving, if you have the right mindset, and if you can figure out a solution to a data science problem, you are welcome. So we are in that great phase of life where nobody is gonna ask whether you are from IIT or any other tier 3 college from a remote place in India. If you have the skill set, you are welcome. We are ready to pay you. And it happens. I have lots of examples. I have myself hired them in my team, right? So there's a lot of scope in data science, but only if you are able to meet that quality. Yeah, perfect. These are some job titles that are available around data science. So you have data scientist, data science manager on the leadership level, data architect who plans the whole pipeline, data engineer who executes that pipeline, machine learning engineer who is more into the model building, right? Decision scientist, statistician. So depending upon, so you saw that there were three domains, right? The business domain, the programming, and the math stat part, right? Now, depending upon which part you are more interested in, you can choose your job profile. Awesome. Moving on, these are some typical trends in job, and it is going to increase, trust me. Okay. Okay. So this is a graph from 2018 and it predicts the size of data that internet will have. What do you guys think? Will this go up or down? So we are in 2023, almost at the end of 2023. What do you think? The predicted numbers in 2018 will are still here or they are much more? What do you think? Let me know in chat. And why? I'll give you a hint. 2020 March. What happened in 2020? We got hit by COVID. Everything become digital, right? And what happens when you become digital? You create more data. Okay. So having said that, having set the context about why data science is very important and why you should, if you have the right passion and if you are really interested, don't look at the money part. Money part is definitely there, but come with passion, I would say. Yeah. Awesome. So let's move on to the main meat of the session, which is sentiment analysis. What is sentiment analysis? So basically, whenever I'm trying to understand the sentiment of anything, text, image, right? It can be a feeling, whether it is on the positive side, whether it is on the negative side, or something indecisive, which we call as neutral. We call it sentiment analysis, right? Very simple sentiment analysis, right? Just like how you analyze the sentiment of your mom and then you ask for certain things, right? Same thing. I'm sure everybody would have done that in their earlier years where you look at the mood of your father and then depending upon the mood, you decide whether I need to ask that I need to go to picnic or with out with friends and so on. So the same thing we are trying to do here. Okay. Why sentiment analysis is important? This this is one screenshot of a recent mobile phone from Amazon. and you can look at the kind of sentiment analysis that they are doing. Yeah, so stars is something that they give, but look at this. So these are the top topics that people are talking about: battery life, camera quality, form factor, low light, build quality, top notch. Okay, and these are the things that Amazon is deriving. Another example, so this is a screenshot from Glassdoor. Now here people are putting, Glassdoor is a website where people just put share, just like you share your reviews on Amazon, right, about a product. You share reviews about company on Glassdoor, right? So before you want to join a company, you would always like to see, what is something good about that company, what is bad thing, right? Before you make a final decision. Okay, so this is we all know Google as a company. So this is the rating of Google, right? And these are some analysis that were done from the sentiment analysis perspective. So I can know what's positive, what the positive things are, and what the negative things are. So basically the pros are positive and the cons mention what are the negative things within Google. Of course, Google is a very big firm, but yes, these are what top people are talking, or what most of the people are talking about. Now, if you tell me simply, it has close to 48,000 reviews, 480. So basically 48,000. T stands for thousands here. Now, do you think a person would be manually reading all these sentiments, all these reviews, and then classifying, okay, these are the top things? Do you think is that possible? A person can read 48,000 reviews? Or do you think there is some data science happening there? There is some scientific thing happening there. What do you think? Is it man or machine? It is the machine that is doing it, right? No person can manually read through all these reviews and determine all this, right? It's very difficult. Another example would be, open your Play Store. You will get what the top feedback, right? What are the top things that people are talking about? Now, do you think a person is looking at those Play Store reviews, right? No. So it is a machine that is doing it. And that brings me to the why part. Because machines are much faster, much cheaper, and much accurate in making decisions as compared to us humans. All right. And these are some other examples. We use a lot of sentiment analysis on movies, on products, right? Public sentiment, politics, and the latest market trends. So people who are in share market, they look at a lot of sentiment about that particular stock, IPOs, and so on. So sentiment analysis is everywhere, right? And we just follow it sometimes unconsciously, but it is around us, right? Even you want to marry somebody, or you want to make friends with anybody, you first take their feedback and then you make a decision. Indirectly, that's also a sentiment analysis. Okay, so I was talking about this packages. So the first thing that we do is import the necessary libraries. Libraries are when good people make it open source, you use it as a library. So in order to use somebody else's good work and build upon it, we have to import that, right? So we call it library. Vader is that algorithm that we'll be using, which had lexicons and scores mapped to it. So happy will have +5, very happy will have +10, right? Exotic will have +7, and so on. So there's a score associated with each term or each word or each lexicon. Okay. Since we are working on natural language, right? So text is also called as natural language. We use this library called as NLTK, which stands for Natural Language Toolkit, right? If you are working with text data on Python, you have to use this library. Yeah, nothing gets solved. And these are some sub functions of this library, okay, which are must have. Okay, then we have counters for the frequency, contractions. Contractions are basically where your words like you apostrophe re will get converted to you space are. So all those short forms get converted back to its original form, right? So that is why we are using those libraries. Is this NLP? Yes, sentiment analysis is a part of NLP, Shubham. So yes. So we have data science. NLP is a part of data science. Sentiment analysis is a part of NLP. Okay. So think of it as a Venn diagram. Data science has too many problems. Within that, NLP is a domain. Within NLP, sentiment analysis is a use case, right? And we'll be solving it on Amazon's review data. Okay. So now what we are doing is we are importing the data. This is how the original data looks, right? So you have a rating, right? Here we are only taking ratings of 1 and 2, yeah, because the data was too huge. So I've just compressed it and took only 2 ratings. You can assume one as negative or low, 2 as high. Yeah, we have title of the review, and then we also have the original review. Okay, so title is just the subject, right, in very short, and review is a big whole open text. So this is how the data looks. The data is 50,000 rows. So I have 50,000 reviews with us, and there are 3 columns, right? You can see rating, title, and review. Since we are not interested in the title column, we want, review column. So I'm taking rating and review. Okay. Then rating is 1 and 2, right? It's a bit confusing. So what I did was I simply made it -1. So 1 minus 1 is 0, 2 minus 1 is 1, which basically means 0 is negative, 1 is positive. So just to make it easy for everybody to understand, instead of 1 and 2, I made it 0, 1, assuming 0 is negative, 1 is positive. Okay. So I just did that. So now you have a revised rating column, and I simply did plotted a graph. So you can see that the data is balanced here. The amount of reviews I have for 0, which are negative, are the same for which I have for positive, which is a good thing. Yeah. This is using the SNS, which is the Seaborn library, where I'm specifying that I want the pivot of, or the count of how many records with rating equals to 0 and how many records with rating equals to 0, rating equals to 1. I'm also specifying the color and so on. And finally the title. That's it. Yeah. So it's simple. Okay. This is where the actual hard work starts, right? Dealing with text data is very different from dealing with structured data. Now, the problem with text data is the amount of variability it has is simply huge. Anybody can type anything. Yeah. It does not have a fixed amount of words. It does not have a fixed length of words. Anybody can write the same word in different manner, right? It's open to interpretation. So there is a lot of permutation and combination that you can do here. So text data is a completely wild thing to analyze. So before you analyze, you have to clean it, right? So just like how your mother brings some vegetable, or how a lot of people around us bring vegetable from the market, but it's not directly usable. We have to do some kind of cleaning. We have to do some kind of chopping before we can actually eat it, or before we can actually send it to the next process, right? So it's not readily usable. The same thing applies to the text data, that it's not readily usable. We have to follow a standard process. Okay. So the first part we do is text cleaning, where using regular expressions are basically finding patterns, where if I find any non-alphanumeric number, if I find anything like dash, apostrophe, colon, full stop, I remove that, because they do not add value to my analysis, right? I'm not going to do anything with the number of colons and full stop. I need words, right? Utilize the contractions library to expand contractions. So like I said, a lot of people write UL, YOULL, right? So it will just make it standard. You will. Okay. Remove numerics. Now, in this case, new numbers are not really important to us. We are only looking at the alphabetical words. So we remove numerics. We replace S. S are basically, whenever you have plant apostrophe S, because we deleted that apostrophe. Now that there is plant space S. So all the plurals, with an apostrophe will get removed here, right? and then we convert into lowercase. Now, why do we need to convert into lowercase? Because a word that starts with a capital letter and a word that starts with a smaller letter, same word, hero wired, right? One with a capital H and other with a small h, computer will treat them differently because in the back end they have different ASCII characters. Okay, then we remove the stop words. Now, what is stop words? Stop words are basically those words that do not add meaning to my analysis. For example, the, up, down, below, under, you, me, I, all these words are unimportant. They do not have a meaning attached to this. So we remove that. Text normalization, right? So here we do something scientific. So go, going, gone. Now the root word for all this thing is same. So we remove the last two or three words so that all the words become similar or same. That is expectation, but at least similar, right? So instead of writing there, I am going, I am, you go, I have gone, the last two or three letters would be truncated so that everything becomes go, go, go instead of go, going, gone. Yeah, that's the idea of text normalization. So what we have done is we have simply created a function for it, right? Pre-processed text, where you clean the text, you remove the stop words. Right now, the good thing is we already have a list of stop words. Some good person has already done it for us. So we just need to make sure to use it, regularly update it, and it will automatically delete it from our textual data, right? And this is the third point, which is text normalization. Let us take an example. So this is before you clean, where you have exotic tales of the Orient, and this is after you clean, right? So you'll see a lot of different words because the last two or three characters have been truncated, have been removed to make it normalized. Yeah, and look at this, Dr. Shen Fu. It has been normalized to this. No capital case, no proper case, no symbols, only alphanumerical characters, all in lowercase, all normalized, so that the text can be as harmonized as possible. It can be as clean as possible. Okay. After all those cleaning, this is how our text looks like, right? Only the cleaning part is done, right? The processing part is still remaining. So I have cleaned the data. Now I do some basic exploratory analysis, right? For example, what is the frequency? We also call this term frequency analysis. So if you have a large corpus of data, you simply look at, okay, what is the most frequently occurring term, right? So so I'll explain code by code. First thing is we divide each sentence into individual terms, right? Then we take the frequency of it. So basically we take the count of it. That is where the counter comes, right? Finally, we sort it. The last part is sorting it, right? And then just renaming the column so that it makes sense to us. So these are the three steps that we do. First, splitting the sentences or splitting the text into individual words, taking the count of each individual words, counting it so that it is descending to ascending. The most frequently occurring words come on the top, and then just changing the column name to make it readable so that anybody who reads the column name knows what it is about. So I can see that the book word has occurred almost 30,000 times. So from 50,000 reviews, book is occurring 30,000 times. So I can easily say that the reviews are generally about books. Then you have one, like, read. There are still some stop words. For example, like is, I don't know what it is saying. I don't understand what it is communicating, right? Read again related to work. Movie is about movies. Would again stop word. So I can also customize the stop word dictionary to make it delete this unnecessary words as well. Okay, so that is one analysis that you can do. Apart from that, the same thing can be visualized, right? So if you want to present it to someone who is more fan of a chart rather than a boring table, so the same thing can be visible. Now just look at the difference in the amount. The first two, book is winning it, right? Other things are still around the same range, but look at the range of book and the second most occurring word. Yeah? Huge difference, right? So that's first analysis we did. Second thing is word cloud analysis. So again, we are just visualizing based on frequency. So this is about graphics. What is the background color you want? What is the width you want? Right? What is the height you want? Whether you want it to be a rectangular shape or a square shape, or uh, or a standing rectangular, vertical rectangular, and so on. So you can do that. And this is how it looks. Now, if you observe, we are not taking ratings here. It is only taking the reviews column into consideration, right? Nothing apart from that. Okay. So this is again an exploratory data analysis that we did. Okay. Now we will do the actual sentiment analysis. Now that you know that, okay, these are the top most frequent occurring terms, let us do a sentiment analysis using Vired. And this is a standard process. You import the library, right? You create an instance of it, and then you just apply it on each record. That is what the lambda function does, right? Because I have 5,000 rows, right? So I will apply it line by line, right? So I'll look at the words in each row. I'll take the sum. I'll take the gross sum, which is there in a whole sentence there might be some positive words, there might be some negative words, and depending upon that, what is the final outcome, right? Is it +5 -3 is equals to +2? So it's a positive sentiment. Is it -5 +2? -3 is the total score. So it's a negative sentiment. So all this mathematical calculation happen. And in the end, each record will have either positive or negative or neutral associated with it. So this is the negative score. This is the neutral score. And this is the positive score. If you add all this, it will combine into 1. So 100% out of that, 10% probability of negative score, 58% of neutral, and 0.3 of positive. Now, because the positive is high here, we are marking it as positive. Okay. Now, pay attention. I have not used the review rating column. I'm only using the text data, which is the review column. The only time I used rating was to analyze it in the starting. Right after that, I'm not using the numerical rating column. I'm just using the text column. So tomorrow, if you want to analyze something, you can simply replace that column name, replace that data frame name, and you are good. Yeah, awesome. And here I'm just dividing the data. Now I have a single data of 50,000 records, right? I'm dividing it into 3 parts: positive, different in a different file, neutral in a different file, negative in a different file, right? And I'm taking individual word cloud. I can also do individual term frequency analysis. That can also be done. But here I'm just taking word cloud so that you can visually see which are the most frequently occurring words. So let's look at the positive first. So I have book, use. These are all the words that are occurring in positive sentiments: love, book, look, know, work, wonder. Now this is negative. You can see bad, wood, album, movie, read. One thing I could, figure this out just at a glance was people are talking good about book, right? Here people are, but I can only see movie in the bad side. I couldn't find movie on the good word cloud, but this is on the negative word cloud. I'm seeing it. And this is for neutral, of course. And since book was a common topic, we can see it in all the three as one of the major contributors. Okay. So that's it on the sentiment analysis side. So if you observed, what we did was, let's have a quick recap. We onboarded the data, right? We onboarded the data. We only kept the columns that was required, which was review, right? Nothing else. Did a bit of exploratory data analysis. First, we did data cleaning, right? Because text data is wild. Anybody can write anything in their own way. So we need to make it as harmonized as standard as possible so that our analysis quality is improved. So we clean the data, we remove the stop words, we make it normalized as much as possible. Okay. Then we do some exploratory data analysis, term frequency analysis, and word cloud, which is a visualization. And finally, we move to Vader, which will, based on the words in the text, it will automatically do some math and figure out what is the probability of it being neutral, what is the probability of it being negative, positive, and finally, it will give you a final sentiment of the whole text. Okay, so that's it on the sentiment analysis side.